But fine tuning the alerting is really, really, really important. So I'm going to go over the agenda, quickly reintroduce myself for those who I haven't worked with in a while. My name is Stevie Prugar. I am a customer success engineer here at NetBeez. My responsibilities include customer management, customer deployments, level one. I help with level one support, things like that. Um, but today's agenda,
Right.
I have I've broken down to three sections. One I have called the tale of three customers. So it's just three data sets. I'm gonna show you them. And then we're gonna actually go back through them and explain, what the conclusions are. It's really important for me and you guys individually to understand exactly what you guys need. So we're gonna go over that. And then there's a several demo points. So the demo is going to take up probably about half of the time period. So it's going to be more live demo heavy than just slides, which I think everybody prefers. So this is the first customer. We have, and I know you can't see this great, and I do apologize, but I wanted to fit all this data on. But we have ping DNS, ping DNS. This top one's Google, this bottom one, some miscellaneous application. And the numbers on all of these are relatively the same. They start at 0, they go to 20, 40, 60, except this bottom one goes to 80. So pretty normal, all things considered. You can see his averages. I'm rounding, by the way. It's like 15, 16, 15, 18, 19, something like that. So averages are look to be good. But what you'll see, and this is a constant trend with this data set, where during the working hours, so this is like in the morning, midday, late day, this is probably when second shift leaves. I suspect there's not much overnight. And this is overnight. You can see that the performance drastically improves overnight. Now, these white spots in between is when your scheduled tests are running. So that's why those aren't failing tests. The failing tests, these little red dots, which are probably really hard to see, that's when a test actually fails. But this average is not really indicative of the user's experience, right? It's a lot higher during the day and a lot lower overnight. And we're gonna come back up and look and revisit this, and I'm gonna explain kind of the reasoning why for that. This is customer number two. And again, ping DNS, top one's Google. Now, again, understanding the um, let me just meet everybody here really quick. Understanding what these scaling is very important because sometimes when you have like big outliers, it's really hard to fit on a chart correctly. So this one goes from 0 to about 50. This goes 0 to 250, 0 to 150, 0 to 250. Um, what's interesting is this is the same target, just DNS versus ping. And you can see averaging around like 17 and a half, 84, 112, 117. These are very high, but they're relatively smooth. So, there are these jumps, but this is a day's worth of data. So these spikes, there's only a couple small spikes throughout the day, but it's pretty smooth. And that's going to be really important when we revisit this not at the end, but shortly here. This last one, again, understanding the axes are really important. Um, they this one goes from 0 to 8, 0 to 6, 0 to 8, 0 to 6 on this one. So averages are just under 9, just over 2, just over 9, just over 2, right? Ping DNS, ping DNS. And this is kind of where we're going to start going into the conclusion is this is very good. This you would think, looking at the graph, not so great, but look at the numbers. When we're averaging 2, a spike to 6 or 8, most, not all, most cases will not be very user impacting at those low levels. At higher levels, when you increase it by 2x, it can definitely be a lot more noticeable. But that kind of latency, that kind of response time is very low. So these intermittent spikes honestly aren't bad. And your ping is very smooth. This is a very smooth line. Like your low side, like your low and high averages aren't even like 1 millisecond off. They're very close. Now, work our way back here in a second. So it's important to note all of your networks are different. Some of you have SLA, some of you don't. Some of you have some tighter requirements, some of you have looser requirements. And that's going to apply to different applications, right? Some things are really important, some things are less important. All of you probably have some similar networking hardware. You might have a mix of it. You might all have different hardware for all we know. So that's going to vary from site to site, customer to customer. And then we have to look at, external factors and network topology, which actually happens to be the situation here. This is most likely a warehouse situation. We've seen this time and time and time again, where the access points are really high. There's a lot of IoT devices. Channel saturation is a problem. Interference is a problem. So the performance of everything is much worse during the day because because everybody's working. There's so many devices on network, and there are some things you can do, but all the warehouse situations we've seen with our customers fundamentally exhibit this similar thing. It's very hard to get a warehouse environment working really well because of how far away everything is, how it is open, but there's also a lot of corners involved. People have handhelds, everybody has a handheld. So you have all these devices just crossing paths. It's a nightmare. And that's what's happening here. So when there's either third shift or very low activity, the performance gets way better. And that's also where, again, you can't see this, but most of the red dots here, they're all here. They're not during the off hours. So definitely a lot of work to do here in this situation, but this is definitely customer impact. This one is interesting. This is when you're behind a cloud firewall, or anything that has to run through a firewall typically, but cloud firewall is going to add a lot of latency. So in this case, this Google ping test does not have to go through the firewall, but to resolve the DNS it does, and then this application does as well. So for this data set, the users are probably used to experiencing this bit of delay. So as long as we're having a smooth performance, the user experience is probably pretty good. What we want to avoid is a lot of spikes and hills and valleys. And some of the data we'll look at on my network, you might be able to see some of it, and that's going to be user impacting. But overall, this is pretty smooth. As long as you're not getting user complaints all the time that they're getting really high latency and response times, then everything's probably working as see fit, and you just want to make sure things don't spike out of control. And we'll show you how to make changes to your NetBeez to help relay that information. So before we go into the demo, two quick slides. One of them, we're going to go over what to consider, and the big one is not over testing. Sure, you can run a lot of tests, but we have found that it can create so much noise, and we're going to dive into that shortly. What issues are you trying to solve or help you with? What data is important, which is less important, and what's actionable versus noise? And we're going to review the data, review historical alerting to review actionable versus noise, and we're going to talk about thresholds, adding performance thresholds to key applications. So with all that out of the way, let me zoom in a little bit so you can see better. This is my NetBeez deployment on my home lab. So I have a bunch of virtual agents, server agent. I even have a few remote agents as well. First things first, I have 51 tests total. That's 51 green blobs here. That is probably about what most of you should be shooting for or close to. 60, 70 is probably fine, but we definitely have had some customers that have gone to the hundreds, which then can cause some server issues if you don't have enough resources. But the agent can handle, a little more. But what you want to look at on each of these tests is if this went red, do I want to know about it? And if I want to know about it, can I do something about it? Is it actionable? And if the answer to the first question or the second question is no, then the question is why do you have that target? And if the answer to that is, well, I want the data for like troubleshooting and reporting, then that's fine. But then we probably should not be alerting on this particular target. So for me, most of these are actionable. Google in particular is important. I have a test for Google DNS in particular, which is why I don't have DNS here. I have all my IoT devices, my local gateway, things a lot of our customers use and we use at NetBeez, and then stuff that I, use as well, because I don't really use Twitter. So most of these are probably actionable for the most part, but personally, like I wouldn't action any of these because I just don't personally use them for me, and I don't really use Twitter, so I wouldn't, set up an alert for those as well. But yeah, it's really important to really look at your targets, really focus on, okay, if this target's not working, would I take action on it? If the answer is no, then do I just want the data? If the answer is yes, then keep it. If the answer is no, then look to consolidate. Now, reviewing the data. There's a lot of ways you can do this, and this takes a little bit of time. So do note that. So you want to maybe take like half hour or so out of your day to do something like this. But I'm going to scroll out a little bit so you can see all four. So I'm looking at just one agent right now, and I'm looking at our Google all of our Google targets here. And you can see these numbers, these average latencies are all like pretty much identical, right? So that's to be expected. They're all Google domain. They're all pretty much hitting the same server. So that's going to be normal. Looking at my internal devices starts to become a little bit more interesting. So most of these are pretty okay. And then there's one outlier, and that is this guy right here. So my Google Home Mini is averaging like 4 milliseconds. My Chromecast is averaging 3. This Nest Cam is 26, and then my server is really low because it's like one hop away from NetBeez server. And this is not good, right? We have these huge spikes in the well into the double and sometimes triple digits. But the rest of these, fundamentally are working pretty well. Now this Nest Cam is in a room that's on the other side of the house from the EP that we have. So, and then in the room that the Nest Cam's in, there's a lot of other devices. So there's reasons why it's probably performing poorly. But when we talk about setting up performance metrics or performance alerting, you really need to understand what kind of metrics you're getting. So things like Google, for example, it doesn't matter if it's like Google Drive, Google Maps, Google Docs, they're usually going to perform the same. You still want to check it, but usually they'll perform the same. But if we pull up Google, Facebook, Reddit, and Twitter, what you'll see here is 2 out of 3 of these also about 24 milliseconds, which tells me the performance I'm getting here is most likely just the routing through the internet or my network. It's not the actual destination that's causing any kind of delay, but Twitter might be because this number is a lot higher than even say Facebook. So I'm assuming the servers are definitely different. Well, now Elon Musk owns them, but so it's important to look at this because what you'll see is I have some metrics set up for things like Google, and I have them set for 30. That would not apply here. This would immediately go into performance alert status immediately. So you want to review the data so you can do it first, do it from like the agent level is an option to try to get an idea of what the data looks like. And then we can go to the actual target and we actually have one of these in performance alert right now, so we'll see why. So I'll look at a few of these here. And you can look at it from the target, look at a couple different agents, right? So we have floor 2, so that's this one. So yeah, yeah, this one just had probably just one spike that really, with these spikes, really set this over a little bit. So for me, I may want to go back, and if this is acceptable data and it's not user impacting performance, maybe I need to take it from 30 to 40. That might be an option. But then you can look at I look at internal nodes here. And I look at the Nest Cam, which is a culprit I have. This one was really interesting that I looked at earlier today. Is that I think, yeah, the averages on all these are all over the place, right? So this one's 26, which is one we looked at before, 22 or 27, 15, and 55. And you can see what's really weird is like this trend and this trend are similar, but this is different. This is different. So this would take a little bit deeper dive into, you know, I probably want to solve what's happening here first before I start alerting on it because clearly the data we're getting is showing that there's a lot of inconsistencies with this particular target. Again, I happen to know what it is. Not really a big deal. Now we want to go into creating alerts. And before we actually do that, I want to show you guys something here. So let's say my Nest Cam, I really don't care if it fails. I don't really care about its performance, but I want the data. What you would do is you would edit the target, and this is only running ping, so you would just uncheck it for, oh, not Google, how many? You'd uncheck it for Nest Cam only. So what that'll do is it won't turn red, it won't log in the system, it'll show up in the graph, and you'll still have all the data. You can still pull the reports on it, but it's not going to annoy you because it's something you just don't really care about or it's not important. You're just, somebody told you to monitor it. Maybe they just want some data on it, but you don't want to be pushing alerts out on it. So I highly recommend removing these alerts from things that you're not going to take action on in particular. So definitely something we're really advising more and more people to do because just alerting on everything is not going to be that useful. Um, so I have your standard 5x5, 5x5 for down up, and then I have these two made. So I have ping 30 milliseconds and 10 milliseconds. I'm actually going to change this to 40. I mentioned I was going to do that earlier. So if we were to make, I'll rename that later. If we were to make a new alert, you have your up down, which is already created at 5. You have your down up, which is your reverse, like a reverse DNS test to make sure your DNS isn't exposed. Baseline, and I do have a video on all these if you want to get a little deeper into it, but baseline is just going to be if the performance degrades more than like 1x, 2x the averages. Watermark is where we want to focus. So this is where you set the metric, whether it's packet loss or round trip time, DNS lookup time, excuse me, HTTP response time. So in this case, I want to explain how packet loss is going to work. So say you set the packet loss to 1%. One failed test in 5 minutes is 1.6% packet loss. So if you did 1%, you would be notified every single time there's a failed test in an ongoing 5-minute period. And then it'll self-clear once it goes out of that period, right, in real time. If you do a minute, it's going to be 8.33%, will indicate one single failure. So that's really good if you want to start catching failures that may not happen in a row. That's a good way for packet loss to be able to get that. The other really popular one, again, is round trip time. Averages 5 and 15 are probably two most common. One's a little strict, but if that's your SLA, then run one. I'm running 5 minutes because I think that's the least. To me, that's a sweet spot where it's not noisy, but it gives good data if there, oh, sorry, it gives good data if there's a problem. 15 minutes, not too bad. I think 1 and 4 hours can be a little long. So once you create these, they're in the same exact spot, so except a little bit further down. So you edit, and you can see my 30, which is now 40, and then my 10. So the check boxes are right here, and then you can assign them accordingly. Now, I do want to show you guys these three tests. This is something to know. So if you want to keep the alerting, but you know the application is just going to be not very reliable, and you really only want to know if there's really a problem, there's a couple things you can do. One of them, so I'm running this ping test every 60 seconds. I don't recommend doing that. That's too infrequent. 10 to 15 seconds, we do see that in the real world quite a bit for some things. Sometimes there's just too much traffic going through a network. It can get blocked, whatever have you. There's a lot of reasons, but 10 to 15 second ping intervals for some applications might make sense. The other option is if you keep it at 5, I have a configured alert here for 10. I would say if you want to go more than 15 consecutive failures before you're alerted, I would question if you should alert or not. That would be a question I would say, hey, you need to ask yourself, should we be alerting if we're going to set this beyond 15? I think 10's probably the longest, 15 maybe, 20 is probably too many consecutive failures where, you're going to have some time pass at that point, several minutes. And at that point, do you want to be alerted or not on that? But yeah, definitely you can increase for ping the timeout to 10 or 15, especially if it's something you still kind of want to be alert on. It's just a little bit too noisy. It's a way to reduce some of the noise by increasing reducing how often, increasing the timeout. That's another thing you can do is increase the timeout as well for especially HTTP tests where those are usually measured in the seconds, increasing the timeout on those. So let me edit here and show you guys. Yeah. So for Slack, HTTP. So maybe set this 10. So if you find these timing out, maybe set it to 10 for a little bit, see if they stop timing out. And if they do, then you can look at, okay, we have something in a network that's preventing this from completing in a reasonable amount of time. It's taking longer. And then you can, use NetBeez and other applications to start going from there. And then incidents. This is something that is really good for outages. By default, they're 80 and 90%. We don't recommend tweaking these too much. But this is going to be good where, if you get an email alert or an aggregate email alert, this agent's failing these four tests. It's like, okay, I'll take a look at it. Suddenly it's like this agent's in incident status. That tells me nothing's working and there's a problem, or very little is working and there's a problem. So definitely highly recommend keeping instance enabled. However you're pushing it through, you have all your different options here. As I mentioned last time, aggregate alerts is recommended. It'll also supersede regular alerts, so it works as regular alert, but it's also aimed to reduce the amount of alert fatigue. So what this does, if you didn't see the last webinar, is it'll sit there and wait for additional tests to complete and try to grab as many similar alerts and package as a single notification. So it does help. If you have an agent that's starting to fail multiple of these in a row, instead of getting like four different emails, you would get one saying these four are failing, as long as they fall within the three test threshold, and it'll reset every time it finds a new one. Um, and then lastly, we're gonna wrap it up here. The alerts API. So I'll be the first to admit this is outside my realm of expertise, but we do have people at NetBeez, Panicos, and Bill, and a few others that are really great with this. But I do want to showcase it. So if you go to settings, API keys, and then API docs, and then you're looking for alerts API. So at a high level, where this is really useful is funneling these alerts out of NetBeez into other applications. Like Grafana is one of them that we've seen, which is really cool to start seeing our customers do that. The big advantage about this is you can really pick and choose what you want to send. So like you can actually do some filtering parameters by groups, which is really cool. So it's like only send the alerts on these agents within this group through the API to Grafana for graphing. So that's really useful. So if you are good with API, I highly recommend taking a look at this because you might really be able to put out some of the most important things you want out of NetBeez into your solutions, and maybe still alert on it in NetBeez, but funneling out of NetBeez, and that's what we're trying to do. We're trying to reduce the amount of noise that's coming from NetBeez to your systems, whether it's an email, whether it's Slack, Teams, whether you're funneling through Grafana with the API, et cetera. We want to reduce that noise. And this is a way where you can really customize like the stuff that's coming out of it. So I know we covered a lot, and I know there's probably going to be maybe not a lot of questions today, but I know there's probably going to be some ongoing questions. And some of you, I have been working with you on this ongoing. As you see, it can be a little bit of a process, but it can really, once you really fine tune it, you can really get some really valuable information, reduce noise. So with that, I'm going to open up to questions. I'm going to start writing down names. And you can just come off mute and ask.
I may have asked you this one time, Stevie, but on those graphs, is there a way to make those so that you could get the Y scale could be a logarithmic scale?
That's not something you've asked. That's actually a good question because as you saw in some of the graphs I was showing, like my graphs are not so bad, but when you start going to historical data, it starts going off.
Uh,
I want to bring up with the team because, as many of you probably know, we're working on a new dashboard that should be out later this year, and we're going to be redoing a lot of this. So that's actually something that I'm going to bring up because that would be very interesting.
because so many times you're sitting there and you're looking at the historic data and you're perfectly fine at 15 milliseconds or whatever, but then there's those outliers that you want to see, and if they go off the graph here, you lose all the rest of the stuff that's in the dirt.
Yeah, because then it's like, for this one, it's not bad, but like my Nest Cam, I think is a disaster, right? When I go to historical, it's going to try to show, and then like you have to cursor over, and because these only run every 2 or minute, whereas yours are going to run every 5 seconds. So I definitely get that. That would be very interesting if there just be a button that just create that switch to like logarithmic, where you'd have basically like powers of 5 or powers of 10 or however that would scale appropriately. So that's very interesting. I will bring it up to the team to see how that could potentially be considered. Any other questions? Like I said, I know I covered a lot. I tried to kind of hit every point. It really just comes down to reviewing the data, removing unnecessary alerting, adding performance alerting to key applications, really just get the data that's important to you and the data that's not to you. Okay, I will kill the recording here. One second.